So there now follows an overview of the SEER machining cost estimator, SEER MCE, capability that sits within CATIA V5. Keith is going to go through, as I say, an overview of the capabilities of the tool, the outputs that it provides, and how it can be calibrated and configured to your particular requirements and your standards and your labor rates, etc., etc. So Keith, it's over to you, sir.
Okay, thank you. So in front of you, you can now see my screen. It's just a standard CATIA V5, and to the top left, you will see the three buttons. The first one being SEER ply cost estimator, second one SEER sheet metal cost estimator, and the one we're looking at today, SEER machining cost estimator. So by invoking that one, SEER will start in the background. This is the costing engine behind all of our CATIA solutions, and it will also interrogate the geometry of the part. Like you can see, we have length, width, height here for this given component. There's obviously a turn component, so we need to tell the model that we're going to do turning, not 5-axis machining as it's saying at the moment. So the model works primarily like the other solutions using manufacturing environments. Manufacturing environments are created by yourselves, by us, to help you to best fingerprint your part family, your manufacturing environment, your capabilities, your experience, your product classification, and so on. So you can build them for long-turn shafts, you can turn them for prismatic parts, 5-axis machining, 3-axis machining, mill turning, etc., etc. And they're done and they're created and they will appear in this drop-down list here. So there's some standard ones in there, and there's also ones that I've done as examples for others. So we'll select turn machining. So then we need to tell the model it's where we're getting it from. So it could be roll stock, it could be a forging, a casting, investment casting. So you can do quick what ifs that it's going to cost me this much money for roll stock, but if I'm making enough, maybe the investment casting would be the better option to reduce the volume removed, etc., etc. So we're going to make it from roll stock. We're going to make 100 of them. It's aluminium or alloy steel. Is a round solid piece of material, and I'll show the display the stock. So that's what we're starting from, and the rules in the environments will determine what this difference between the finished component and the raw stock will be. You have the ability to control that within the environment. That's pretty well covered. Round solid. So if I said it was round tube, it would assume there's a hole up the middle, and we'll do that in a minute as an alternative method of production. Rectangular, which is never going to be round solid. Our roughing operations, so this is where we decide whether we're going to volume rough turn it, detailed rough turn it, volume rough boring, detailed rough boring, etc., etc. So basically, we're going to control that with our rules, but today we should be able to. It was there then. Turn that one off. That one off. And we'll leave the other 4 on for roughing. For finishing, it's highlighted and grouped all of the surfaces together, and we can have a look at them. We can edit the groups, we can make changes to them, we can exclude them if we want to, but we want to turn it complete, so we're going to leave everything in place. So once you've been through and had a look at all of the information, it'll highlight what we're actually trying to do at the moment. We're sort of turning these undercuts and diameters here, and so on, and some boring at the middle, finishing, etc. Drilling holes. So we've got our holes on the outside here, and we've got probably a tooling hole over here. We're drilling it with carbide, and again, we can edit these if we wish to, but basically that's coming forward from the environment setting. So we're ready to go, and it's simply a case of clicking on the estimate button. It's gone off, it's embedding all of those operations now into SEER for manufacturing, creating an estimate and bringing that back in here in real time. So it's created an environment, an estimate, and we can show SEER, and we can look at what it's created, its machining operations, and all of the operations. So it's doing some finishing. If we look at the finishing, you again will control what it's doing. It's doing some blasting, some solvent cleaning, and some painting. Maybe we don't need those operations. They can be excluded from the estimate in the future. So if we go back, we can minimize this one. We can modify the estimate, go back to the beginning, and maybe look at our part inputs. We'll say turn mill, choose that one there. Solid, exactly the same. Rough operations, the same. I'll leave them on. Turn off tooling, surface finish, turn off the finishing heat treat, click on the estimate, and again, we'll come back with a new time, greatly reduced because I've turned off the tooling. We've also added some operations in, so we're ending up with a good time to complete the estimate. Now, I spoke of the environments. Now, the environments are what are controlling this component. They're in this list here. Now, if I take you to that directory where they reside at the moment, this is them here. So we can create one quickly for ourselves. So we'll just copy one, and we'll paste into there, and we'll rename it. And this would be your factory name. It could be your initials. It could be turn shafts, hard turning, soft turning, milling, whatever you wanted it to be. So I'll go into that one. So these are all of the knowledge bases that it will create when we do it. This is the file that creates the knowledge base, and this is the rules editor. So if I go into this one, we'll make a few simple changes. We'll change it to sterling. No, we won't. We'll go to euros today. Raw stock, alloy steels, round tube. I'm going to start from tube by default. We'll actually make it out of something different as well. Come down the list. Nickel alloy. Tolerances, we'll make it 0.1. Deburr, finish heat treat, tool. So these are going to be no by default. Yes, we will deburr it. Semi-automated NC machining. And then this is information relating to the bounding box. Round diameter excess 25, that's too much. We only want 5 millimeters for our components. A few other changes, we'll just make some options. We'll make that 3 and 3. These are the options. So volume rough turning. So we don't want that one. We're going to change that to a no. That one to a no. So we don't have to water them again. Come down on our list. And this is where we can start to talk about our turn surfaces. So we can say that maybe our feed per tooth is 0.05, 0.05. So we're going to slow it down. We've got some high finishes. It's just random changes. And we could do depth of cut, deadhead percent, exactly as we wanted it. We're just making some changes just to show you what you can do. Information about the tolerancing, surface finish management, hold tolerances, cutting away the raw stock. So this is where we're having setups, the setup complexity. So we'll say the setup complexity is lower. It's going to be nominal. So I just made some random changes just to show you what we can do. And at the bottom we have information about the materials and so on. So that's one stage done. So I'll click on save. Coming back now to SEER for manufacturing, and the other file that's important is the knowledge base file, which will open up. This contains a standard SEER for manufacturing file, but the difference this time is going to be that when we save this file, each file will be saved as a knowledge base for ready to use within that environment. So let's take a look at what we're doing. So we want to change our labor rates to 65. I want to change that to 65. Product classification is good. Our capabilities, we'll say, just make a change. Labor calibration is okay. And we don't have any labor wraps and fees. Process specific, this is all coming in from the interface. The material choices, utilization, setup complexity is going to be set. The little notes, text rules, interface, and so on. So dependent upon where they're coming from. And we can copy again these few items here. Copy that, paste that in there. Okay, we'll save this file and close it. Now, if we go back to this one here, we run the macro. It's now going to save and update all of the rules and everything associated with this environment. So it's going to open MFG and create a knowledge base for every line item within that file, which is doing down here. It's creating this file here, running through it. Saved. Okay, we can minimize that, close that. We'll restart CATIA so we can see our new file. Reopen the part. There we are. That's our component. Zoom in a little bit. Open the machining interface. So now we're going to select our kg edit. We're going to make 10 of them today. So we have our new material. We're starting from round tube this time. You can see that in our stock outline. We have our roughing operations, and we turn these off, so they're no longer coming on by default, which is what we wanted. We did nothing to do with surface finish other than some of the machining feed rates. We changed that, which we'll see later on, and we can estimate and come back with an estimate for this one. So we can save the file. And we can modify or show here, sorry. Here's our operations, process specific. Coming down the tree, we can see per rev. This is where we changed that. We put a slower cut in here. So that one has been altered for that group of families. So for our machine details for turning a diameter, we're now finishing it with a much slower cut. And obviously that's been reflected in a greater time over here. So that's how you can tune the model. If we go back to SEER for manufacturing, you'll be able to see that we have operation details tab here, and we can see the operations that were undertaken. So we've got some setup minutes, some direct minutes, and so on in detail there. Detailed operation gives us a bigger report with more information relating to setup minutes, rework minutes, direct minutes, and so on and so forth. So that is how the model works. That is the resultant estimate in SEER for manufacturing. And again, if you wanted to now, you could insert, I don't know, we could change this one. We just close that. Window, arrange all. Come down to the bottom of the operations. Add an operation here. And I could say I'm going to drill an additional tooling hole. Not on the drawing. One of them, it's going to go through, I guess, 9 millimeters. It's going to be an 8 millimeter diameter hole, and I can add that operation into SEER now, and that will appear in my operation list in the same way as it did before. So you have the resultant estimate. You can modify that estimate. You can add further operations, further components, with the full benefit of everything to do with the native SEER if you need to. So finally, we close this one up, go back, and again, we have all of our SEER, all the groups of them, all the holes that have been highlighted over here that we can look at. So that's SEER for manufacturing and the CATIA machining interface, and back to Steve.
Excellent, thank you, Keith. As I say, when we started, that is a general overview of the capability, and I'm sure has created some questions in your mind, which we can address in a follow-up session and via email as well. You have our details. Please feel free to get in touch with us when you have those questions. Thank you for your time. Thank you, Keith. Very much appreciated.
Welcome. Thank you.